I got a quick report on some physics shenanigans. Here we have a circumstance where a one mass hits a two mass. The one mass has, say, 100 momentum. The two mass will leave with 130. It's clearly free energy being created because it's free momentum. So the reveal, do it. Jeez. All right. So it's 3/4. Instead of it coming out half the speed, the twice as heavy object should be half the speed to conserve energy. It's not half the speed. It's 3/4, 2/3. I mean, and therefore it has 130 momentum. It's a third more momentum than what went in that direction. So we collect energy in a direction. It's free energy. It's a paradox. It's not explained. There's something wrong here. Somebody should have an answer.
As you can see, this video was uploaded on July 2nd, 2021. This is basically where it all started. Since then, draft science has been provided dozens and dozens and dozens of more experimental evidence that proves that no, this is not a paradox. This is literally what nature does. This is what actually happens in an elastic collision. Here's a brief overview of draft science belief. He believes that momentum is the same as energy, therefore he treats momentum as a scalar instead of a vector. This means that momentum always have to be added, no matter in what direction an object is going after collision. According to draft science, momentum always has a positive value. However, every experiment proves him wrong, including this experiment done by Professor Lewin. Therefore, he says he can't be true, it's paradoxical, something must be wrong. Now, this video was uploaded 4 years ago, and dozens of experiments later, till this day, he argues exactly the same thing.
So in this case, they have this idea that you have a one mass and a three mass in a Newton's cradle, and you swing the one mass in, okay, and the three mass ends up with 150% of the momentum. So you have 100% momentum here going in, and you end up with 150% going this way, and you end up with 50% going this way. So you have now increased your total momentum from 100 to 200. So now you have 200 momentums in the system. You have an object going this way with 150, you have an object going that way with 50, and they're both going to come back together again. It's ridiculous. Ridiculous. It's a ridiculous theory.
No, Gary, your brain is ridiculous. Let me now show you to what insane levels of denialism this person will go. So first, the Professor Lewin experiment, he came up with the excuse that Professor Lewin cheated the experiment because of the blob of clay on one of the carts. Therefore, he so-called cheated the actual mass ratios. Professor Lewin said the small cart is half as heavy as the big cart, but according to draft science, he's lying, and he is deliberately lying at every single student sitting in that room, including every person watching that lecture on YouTube. According to draft science, he manipulated the masses because he doesn't want to unveil the truth that kinetic energy is not real. Walter Lewin is hiding that truth from the masses. LOL. The problem was that Professor Lewin didn't weigh the masses on camera, so therefore I showed draft science other air track experiments where they did weigh the masses in front of the camera, and guess what? Of course, the experiment still proved him wrong. He then came up with the pathetic excuse that it was recorded from a bad angle.
It's so bad, right? So it's this terrible video quality. It's a terrible camera angle. The weights are bizarre numbers.
Later on, he came up with an even more pathetic excuse that air track experiments in general are basically flawed because the air that flows through the pipe might cause a little extra push, therefore creating some extra momentum.
Air tracks are got to have them level, and there's air pressure you're pushing up. It's introducing a force. If the cart tips a little, it's going to move. Lots of flaws. And so
in this way, draft science has now come up with an excuse to deny every single air track experiment. There also are collision experiments done with carts with low friction wheels. Of course, all of them prove him wrong all the time, but again, draft science came up with an excuse that the so-called extra free momentum is actually stored in the rotation of the wheels.
In this case, the light cart hits something, and I think it only has, a certain MV because of its linear motion, but it has a whole bunch more energy stored in the wheels. And so when it hits a surface, it transfers that rotational energy into linear energy, and so it impacts something much more aggressively, as if it had more MV, more velocity than it actually has. So that's where they pretend the kinetic energy sort of argument is they're thinking the linear motion is the actual energy of the object when its linear motion is only a portion of its actual energy.
In this way, draft science now has an excuse to deny every single experiment done with carts with wheels. So now he doesn't need to bother anymore about every single collision experiment being done in every physics class around the world because it's all flawed and there is a hidden reason for why the results don't come out the way he wants. So then he proposed to do the collision experiments with pendulums like a Newton's cradle, but with different mass ratios. He discovered a video on YouTube that showed a 1-to-3 mass collision video. So conventional science says that after collision, both balls will reflect with half of the initial velocity. But according to draft science, they must reflect with only 1/4 of the initial velocity.
They're saying this velocity is 1/2 the original velocity this had. And no, it's not. It's 1/4. Okay.
However, someone analyzed the 1-to-3 mass ratio collision, and once again, he got proven wrong. But yet again, draft science came up with more excuses.
All right, so my argument would be is this one clearly doesn't have 150 momentums, but whatever. and that really what it's done is taken 75% of the energy is now moving the 3 mass, and 25% is what you get as a reflection.
So at this point, I started doing a whole bunch of 1-to-3 mass ratio collisions myself. I analyzed them using a digital ruler. I also analyzed it with a physical ruler. It all proved him wrong. Then draft science said the arcs were too small, so I can't simply measure horizontal distance. I have to measure the lengths of the arcs, which I did, and once again, it proved him wrong, but he just came up with more and more excuses as always. I analyzed a collision using a software tracker that tracks the balls and calculates their velocities. Once again, he was proven wrong. I also used my timing gates to measure the velocities. Once again, he was proven wrong. I also used a simulation video and overlapped with my physical experiment, and both the simulation and the real experiment perfectly aligned, showing crystal clear that yes, both balls reflect with half the initial velocity. Once again, draft science came up with excuses that the energy input was way too small. So I redid the experiment, putting in more energy, and once again, it proved him wrong. And once again, he came up with more excuses. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 different collision experiments analyzed and measured in various ways, performed with different masses, different pendulum lengths, different cameras, and different measurement techniques. Every single fucking one of them proves conventional science, right? And Gary simply says that all of them are garbage experiments which are horribly flawed. But what a coincidence that all of them happen to match the predictions of conventional science. Now, what does Gary have? Absolutely nothing. He has literally 0 examples of pendulum collision that come out his way. Fucking 0. All right, next, the launching experiments. Gary or Goofy or Gooftard proposed the experiment where you launch a 1 mass and 2 mass each time with the same energy input. According to him, the first mass should travel twice as fast than the second mass. However, according to conventional science, the 1 mass only goes 1.4 times faster. So this experiment has been done using springs and rubber bands to begin with. Each one of them proved the 1.4 result correct. Goofy obviously rejected every single one of them, calling it garbage as always, and later on, he came up with another excuse where he said that springs are not good at launching different masses. They are good at receiving energy, but not good at reflecting energy.
If you shoot a light object, you can understand that the spring itself has to move the same velocity as the object it's pushing. And so as the spring is moving out, it's going, let's say, 5 velocity. And this is going to be a heavier mass, 5 times heavier, so it's going to move 1 velocity, theoretically. The problem is with this lighter object, once the spring is going 5v, and there's a point where the object is going a little bit faster than the spring is going. The object is going to leave the spring. It leaves contact. And when it leaves contact, the spring has to be going just the tiniest bit less fast. So the spring has the 5v velocity. And that means the spring can't give any more energy to the object, and the spring is just going to be stuck oscillating with that velocity stuck inside of it. And if it moves a heavy object, obviously it's going to be going much slower. The spring's only going 1v when the object leaves. So the spring has a lot less energy left in it because it's only going this very slow velocity. So it's going to oscillate very little. So you can understand that the energy left in the spring, depending on the mass of the object, will be different. Substantially, I'd argue different. But it's just a fact that you can't rely on the notion that the spring is always going to give the same energy to the object, because it can't.
So Goofy always uses this argument for every single launching experiment done with a spring or rubber band with different masses. In this way, he can now deny every single launching experiment with springs and rubber bands. But I bet you, if it proved him right, he wouldn't have searched and searched for an excuse. So now, up to the next type of experiment. Since Goofy said that springs are only good at collecting energy instead of giving away energy, we decided to do vertical dropping experiment on a spring, dropping many different masses from many different heights, including dropping a 1 mass from 4 times the height and a 4 mass dropped from 1 height. Once again, it all proved him wrong, and it proved the equation E equals mg h right every time. And as always, Goofy can only reply with more excuses and denialism.
This example was just so bad. This is the experiment where the spring pops inside of the mass. It's just useless garbage. Just nonsense. Piece of absolute steaming shit.
Per centimeter. So these velocities aren't right. So even though the other mass is going 2 units of velocity, and this is going 10 units of velocity, it's still supposed to be just 5 times faster, not 10 times faster. And it looks like more like 10 times faster. So
now Goofy always prefers to guess the velocities rather than actually measuring it because he's lazy as fuck. No, Gary, it doesn't look like 10 times faster. Here I have measured the velocities with the tracker software, and it calculated that the one mass went approximately 4.66 times faster, which is a lot closer to 5 times as fast instead of fucking 10 times as fast. Once again, Gooftard was proven wrong, and the coward, of course, ignored it.
Well, clearly the other object wasn't moving fast enough, or for some reason this one possibly can't be moving can't be moving faster if the height is anywhere near right. So I'd say obviously the problem is with the speed, which was the heavy mass is falling because there is friction or something with the pole. You can't really see it in this. Let me go a little further, and you can sort of see when it crashes that it tilts a little bit, indicating that this one has a lot more bubble in it. So you can see it moves a little bit to the right to left, and then it's 10 for the rest of the way down to 8. So there's just no consistency in it. There's no pattern. It just seems obvious there's a mistake somewhere. It seems this first number is way off, but who knows? It's just junk, frankly. It's a junky experiment done with too small a spring, blah, 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 blah.
He also complained that dropping masses on springs only show a couple millimeters of difference each time. So I decided to drop masses onto rubber bands where the deformation is way larger each time. Once again, the results proved E equals mgh correct. However, since a rubber band is a lot more flexible, we are dealing with standing weight each time. When a mass is resting on the rubber band, it already produces a certain amount of stretch. Now, when you drop the mass on the springs or rubber bands, you have to subtract the maximum stretch with the standing weight stretch. Here's the reason why. Imagine a trampoline that already sags a bit when you stand on it. If you step off a chair and land on it, it goes lower. The extra bounce depends only on how much further it compresses beyond the sagging amount, because the sag itself just balances your weight. The same principle applies to the spring. The standing compression supports your weight. The additional compression comes from the extra energy you added by dropping. However, Goofy came up with an excuse that you don't need to subtract the static weight with the maximum stretch or compression. He does this because in this way it favors his momentum is energy belief.
Wanting to go this way. So I can't add weight to an already compressed rubber band. So it's a good reason to understand that the static weight is irrelevant because the momentum has already compressed the rubber band much deeper into a much higher force. And the 1 pound just can't weigh anything. It can't increase the force because I'm already way heavier than the object I'm adding. So,
in this way, Goofy can now deny every single dropping experiment where we have a certain amount of static weight compression. I therefore have done more dropping experiments where the static weight is minimal. However, I only got more and more denialism and excuses.
It would be best to probably do all of these experiments linearly, okay?
And so that's what I've done. I have done dropping experiments horizontally onto a rubber band so that there is no static weight at all. I dropped many different mass from different height, and yes, once again, it proved E equals mgh correct as always. And I don't have to tell you, Goofy once again rejected all of it and provided a whole bunch of excuses.
It does okay-ish slow motion, but it's garbage lens. It's a whatever you call that, wide view, and it creates insane amount of parallax.
However, I was able to undo the fisheye lens. Here you can see that the view from left to right is perfectly normal, no distortion at all. However, I did move the camera a couple of times, but I proved that there was no parallax problem.
It says there's no goddamn parallax problem. So he's taking an image of the same thing. I'm saying it's the same event. And he's taking the image from 2 different camera locations, and he's saying there's no parallax problem. It's impossible to say that, so the video is goddamn shit.
Here's the one mass, the same event. So 33.2, then I move the camera more to the left. I repeat the same event, and I read 33.3, only 1 millimeter in difference. I once again move the camera more to the left, so the third location. I repeat the same event, and what do I see at 33.3? No difference, absolutely no difference. And here you are claiming, yes, there is a parallax problem. No, there isn't. I have physically proven it with real physical evidence. You don't.
Conclusion, Goofy the Gooftard is pathetic as fuck. Next, dropping balls into clay. This the typical experiments performed in the 18th century by, for example, Émilie du Châtelet. It showed that when a ball is dropped from 4 times the height, it produced 4 times the amount of indentation, thereby proving the kinetic energy formula. However, once again, Goofy came up with an excuse for why using balls is not a good idea to measure kinetic energy.
And people like Bruce Journey or Steve Mould or somebody needs to say the words that this experiment has no theoretical hope of getting to a right answer. So you drop 2 same object, you drop one at twice the velocity. So you have it hit the surface with twice the velocity. And you compare the two, and there's actually a displacement, that is a crater created that's 4x the size for the one with the 2v. And the simple explanation is well, yes, as you increase the velocity, if you're just going to dent the clay, that is, you're not going to penetrate the clay, okay, and have the object end up in some place, then the surface for the 2 experiments is very different. This experiment, the surface was mostly this, and this experiment, it's more this, okay, up and down. So obviously this is like an arrow argument. A pointy arrow goes further. It doesn't mean it has more energy. It means that its shape is conducive to creating more displacement with less work.
I then showed him an experiment where I dropped a 1 mass going twice as fast and a 2 mass going half as fast. According to Goofy, they should produce the same impact because they have the same energy. Even though it were also little balls penetrating the foam, if they have the same energy, both balls should penetrate the foam to an equal diameter. However, that's not what happened. The one mass going twice as fast went deeper. However, Goofy used the same argument for why balls are bad at proving kinetic energy. LOL. I then dropped a 1 mass from 4 times the height and a 4 mass from 1 height. They produced almost identical indentations, proving the formula E equals mgh. Goofy, of course, rejected the evidence. I then dropped a 1 mass going twice as fast and a 2 mass going half as fast on little sheets of aluminum and onto cookies. Each time, the first mass was able to tear apart the sheet and fracture the cookie, but the second mass wasn't, meaning the first mass had more energy each time. However, Goofy came up with an excuse for why faster things are able to fracture materials better, but that doesn't mean it has more energy.
One, the object with twice the velocity would break the foil when the one with half the velocity wouldn't, because we already know that from like karate and lots of other things that you don't need more energy, you just have to deliver the energy fast and that'll break things. So we know that high velocity can fracture things. A little tiny pebble can break a window, and you can throw a heavier rock at a much slower speed and it would bounce off. So
I then once again dropped a 1 mass going twice as fast and a 2 mass going half as fast on a clip, this time such that the clip would slide over the bar. Since both cases have the same momentum, then according to Goofy, we should see the same displacement. Of course, that didn't happen. The 1 mass produces roughly twice as much displacement, exactly how conventional science predicts it. However, once again, Goofy came up with an explanation for why this happens, but it doesn't mean that the 1 mass has more energy.
So obviously, with this clothespin gimmick, it's the same idea. It's a constant force, but it's friction. And friction has a static component that once you break it, okay, then you can slide much easier. And the faster you get that pin moving, the less contact it's making with the surface per centimeter or millimeter. And obviously, the less it's going to be rubbing or heating or in some way transferring its energy to the contact, through the contact. The clothespin is getting hot slower. The piece of metal is going to get hot slower. All of those things will happen less dramatically because there's less contact, less friction. All right.
Next, the balanced lever experiments. This is another big chapter regarding inertia. So Goofy claims that when you have a lever and you place a 1 mass at twice the distance from the fulcrum and you let the lever swing, that it will oscillate in exactly the same way as when you place a 2 mass at half the distance from the fulcrum. In both cases, the lever will indeed balance at rest. But when you let them swing, it will always require more time and energy for the 1 mass to lift the lever. This is due to inertia. Of course, Goofy rejects and denies inertia. It proves that the 1 mass has more energy than the 2 mass. We have dozens and dozens of experimental evidence, but Goofy rejects and denies literally all of them. In total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 lever experiments, and I probably left some out. Every single one of them shows that it requires more time and energy for the 1 mass to swing the lever, and of course, Goofy calls all of it garbage and crap. Goofy in fact performed a lever experiment himself, but it proved himself wrong. He didn't bother to measure the velocities. Instead, he just looked at it and assumed it went twice as fast. But when analyzed carefully, it only went 1.6 times faster at best.
Again, and maybe I can move this as I cut the string. You can see it goes way off the screen, really fast, really fast, really fast, really fast. It's really fast, really fast. Barely, whatever, 6 inches. Barely. Should move this. Yeah, I can see that. So there's 4 of these. But yeah, not, obviously half the velocity. Kind of obviously half. Obviously.
Next, the coupled oscillators. This was also an experiment proposed by Goofy. In this case, we have a 1 mass and a 2 mass suspended with strings. Both strings are also attached to each other with a string. When you let one of the masses swing, it will slowly transfer all of its energy to the other mass. According to Goofy, when the 2 mass has given all of its energy to the 1 mass will go twice as fast. However, in reality, it will only go square root of 2 times faster or 1.41 times faster. I have also repeated this many times, and each time the 1 mass went between 1.4 and 1.5 times faster, but never twice as fast. Goofy, of course, came up with endless excuses for why the experiments weren't done well enough. In total, I have done 6 coupled oscillator experiments. Each time I have changed the setup based on Goofy's excuses, and each time it kept proving him wrong. Last words, this gooftard is an incredibly pathetic evidence denier. He has been presented so much evidence with consistent results, yet to this day he claims there exists 0 evidence for the existence of kinetic energy. Well, fuck you, Goofy. Enjoy the rest of your life in your Goofy cave shouting at your computer.